Hi everyone, R programming loop.
Hi everyone, today I will teach you on how to do loop in R. Loop is very important if you want to do iteration or repeated computation in programming. In R, there are three types of loop in. Okay, the first one is for in. In R, a while takes this form where variable is the name your iteration variable and sequence is a vector of list of values. So when we do the for in loops, so we have for variable and then in and then the sequence and then the expression. Okay, for example here, for I in 1 to 10, so this is the sequence. Okay, print square root of I. Okay, so it will produce the value of I from 1 to 10 squared. Okay, so we can copy paste this one, right click, copy, paste, and then run. So it will produce a square root of I from 1 to 10. Okay, however, the for in loop takes a lot of time to run the process because it will compute iteratively one by one, not simultaneously. Okay, another example. Okay, let's say we have a list with 3 vectors. Okay, the first one is the character vectors, the second one is the numeric vectors, and then the third one is logical vectors. Okay, so let's say we want to have the list of object named fruit here. Okay, and then you can copy this command. Okay, right click, copy. Okay, so if you run all this, okay, so you will get the object of fruit in a list form. Okay, so there are 3 object, okay, and the fruit object, okay, which are the character vectors, numeric vectors, and the logical vectors. Okay, and then in for in loop, okay, you can also do some computation or iteration. Okay, for example here, let's say we have this vector, okay, and then we want to determine in this case we want to determine the even number, okay, in the vectors. Okay, so let's say we copy this one, paste. Okay, so if we run all this, run, okay, so it will return to you the number of even number. Okay, so we have the initial value count is equal to 0. Okay, we start from 0, and then for val in x, okay, so if val this one is the remainder, okay, over 2 is equal to 0. Okay, so therefore count is equal to count plus 1. Okay, so meaning that this is even number, so print count, so it will count how many even number in the vectors here. Okay, so in this vector the even number are 2, 8 and 6. Okay, that's why you get the output is equal to 3. The second types of loop, okay, is a while loop. Okay, so loops are used in programming to repeat a specific block or code. Okay, So this is the flow chart of the while loop. Okay, so it will do the computation iteratively, okay, until it reach certain condition. Okay, for example here, let's say we want to print the value of I, okay, 1 until certain value with the condition until I is less than 6. Okay, so we want to print 1 2 3 4 5. Okay, so we can use the while loop function. Okay, so you can copy paste this one, right click, copy, okay, and then paste here. Okay, so the condition, first you must have the to use the while loop function. Okay, you must have the initial value I equal to 1, and then follow the while function while the condition, okay, I less than 6. Okay, and then the body here is the operation and the output. Okay, print I, and then I equal to I plus 1. Okay, actually if you change the sequence of print I to I equal to I plus 1, okay, it will turn out otherwise. For example here, let's say please, okay, if I change the sequence here, cut, and then write the I equal to I plus 1 first, and then print I, so it will start with 2. Okay, because we start with I equal to I plus 1 and then print I, and then it will print until 6 2 3 4 5 6. So that is different if you change the sequence of the operation in the curly bracket here. And then in the while loop you can also have break if you want to ask the programming to stop and then compute at the breaking point. For example here, let's say we want R to iterately find I until less than or equal to 6, and then if I equal to 4, and then break. Okay, break meaning stop, and then print I multiplied by I, or I squared. Okay, so you can copy this one. Okay, remember in while loop you must have the initial value. Okay, or else you cannot use the while loop function. So in this case the initial value is I equal to 1. So this is the condition while I less than or equal to 6, and then this is the operation. If I equal to 4, break, and then print I squared, I equal to I plus 1. Okay, so you will get run. Okay, I equal to 1, I equal to 2, I equal to 3, and then for I equal to 4 it will stop. Okay, it will not print for I equal to 4 and above. So that is the function of break in the while loop function. Okay, and then you can also have next. Okay, next meaning that you skip. Okay, for example, let's say if I equal to 4, okay, and then you can skip, so that the operation of 4 times 4 equal to 16 will be skipped in the iteration. Okay, for example here, let us use this function. Okay, so the initial value I equal to 1, while the condition I less than or equal to 6, and then this is the operation. If I equal to 4, okay, we print I equal to I plus 1. Next, print I multiply by I. Okay, and then it will compute until I equal to L equal less than or equal to 6. Okay, so we run this one. Okay, so as you can see that we have 1 squared, 2 squared equal to 4, 3 squared equal to 9. Okay, 4 squared, remember this one. Okay, next kita skip. Okay, and then proceed with 5 squared. Okay, and then 6 squared. Okay, so kita berhenti sampai 6 squared because the condition is while I less than or equal to 6. So this is how to use the while loop with next function in the operation. The next one is if else. If else also is very important. If you want to write a function with 2 different statement. Okay, for example here, okay, if x, let's say we put the input here, x is equal to 5. If x greater than 0, so we want to print a positive number. Okay, for example here, okay, let's say we copy paste here, copy, paste, okay, and then run. Okay, so since here x is equal to 5, okay, so x greater than 0, so it will print positive number. Okay, so let's say f is equal to negative 8, for example. Okay, so if we run, okay, it will produce nothing. Okay, because x, okay, is not as negative 8 is not a positive number. Okay, if you have another option in if statement, you can use else here. Okay, for example here, let's say x equal to negative 5, and then we want to return the negative number if we give the input negative value. Okay, so let's say I copy paste this one. Okay, and then run all this. Okay, so x negative 5 will be written as a negative number. Okay, or let's say if I change x is equal to 9, and then it will return non-negative number. Okay, let's say if we have another output, okay, which is 0, okay, then we can do a nested if else. Okay, so here let's say x equal to 0, so if x less than 0, the condition if x less than 0, so we ask R to print negative number. If x greater than 0, then print positive number. Else, in this case, if x is equal to 0, then print 0. Okay, so let's say we assume that x is equal to 0. Okay, copy and then paste here. Okay, so if we run here, so you will get that x is equal to 0, so it will return to you the output, okay, in the character vector 0. Okay, because here x is equal to 0. Okay, so let's say if x is equal to negative 3, okay, so automatically it will return a negative number. Okay, and you can also use the if else function, okay, so that you can reduce the if else nested operation here. Okay, so let's say we have this vector, yes, okay, and then we want the output of getting even and odd number. Okay, so we want to L to determine, okay, whether each of the element is even or odd number. Okay, so we can use the if else. Okay, so if else, okay, and then the condition, okay, if true is even, and then if not, we assign as odd. Okay, so we use the if else here. Copy and then paste. Okay, so if I run this one, okay, so automatically it will return the character vectors that represent the numeric vectors in A. Okay, so 5 is odd, 7 is odd, 2 is even, and then 9 is odd. Okay, so the next one is the apply function. Apply function is used as an alternative to loops. The first family function of apply is apply in a bracket. Okay, takes data frame or matrix as an input and give output in vector, list or array. Apply function is primarily used to avoid explicit uses of loop construct. So we can compute the mean, or you want to find the sum simultaneously. Okay, you don't have to do it one by one, so you can use the apply function. So this function takes 3 arguments. Apply, x is the data, margin, you can, let's say if you want to find the mean for column, so you can decide margin is equal to 2. Okay, so if you want to compute the mean for row, so you can set margin equal to 1. Okay, and then the function. Okay, if you want to find the mean, so you put here mean. If you want to find the standard deviation, you put the function here as the standard deviation. Or if you have your own function, okay, you can put under apply here. Okay, so refer to the iris data. Okay, so if you still remember, if I view the iris data, okay, so we have 5 column. Okay, let's say I only want to have these 4 column. I want to find the mean for sepal length, sepal width, petal length and petal width. Okay, so therefore, okay, I will exclude species from the computation in the apply function. Okay, so how to do that? Okay, so apply, okay, you can type apply, and then the data that you want to compute, okay, is the iris data. Okay, but you want to remove the 5th column. Okay, and then since we want to compute the mean by column, okay, so therefore the margin is equal to 2. So you don't have to write margin, just type 2. So it's understand that we want to compute the mean by column. Okay, and then the function, let's say we want to compute the mean, so type the function which is the mean. Okay, and then run. So it will return to you the mean for each column in a vector form. Okay, so that is how you run the apply function. Lapply is a function to perform operation on list object. It produce the same output, but the output is in a list form. Okay, for example here, okay, let's say if you want to find the mean for each column, okay, in the iris data, sepal length, sepal width, petal length, petal width. Okay, and then we want to use the lapply function. Okay, so you can just type lapply, Okay, remove the fifth column and then compute the mean. Okay, so it will return to you the output of mean for each variable in a list form. Okay, so that is lapply. The next one is sapply. Sapply work as similar as lapply, but the difference between sapply and lapply is sapply will return the output in a vector. Okay, the output is similar as apply, but the command is the same. So we put here as apply. Let's say we want to find the mean. Okay, so the output is the same as using the apply function. Okay, the output is in a vector form. Okay, and then tapply. For tapply, we can compute the mean, median, minimum, maximum for each variable according to the factors. For example, here if we refer back to the iris data, okay, the iris data we have a column of species. Okay, so there are 3 different species: Setosa, versicolor, and virginica. Okay, so we can find the mean for the mean of sepal length, sepal width, petal length, petal width according to the species. Okay, so how to do that? Okay, so we use the tapply. Okay, so first we must know what we want to find here. Let's say we want to find the variable of interest is the sepal width. Okay, and then we want to find the mean of the sepal width according to the species. Okay, so you can type here tapply. Okay, so iris, so the data that, let's say we want to compute the mean for each species, the mean of sepal width. Okay, and then iris according to the species. Okay, the function is mean. Okay, then run. Okay, so it will return the mean of sepal width according to the species. Okay, so that's all on the apply function. Okay, you can try out the exercise 9, okay, and see how you understand the concept of loop and apply.
Thank you for watching.